But the issue really is one of can you dispatch enough energy at the right times? And that's why I gave you quite a variety of different projects here today to show you how we can do some daily shaping with just balancing ponds, right to baseload facilities like the Dunvegan project, which is a 100% capacity factor, 100 megawatts full out every day. And so between the mixes of different project level opportunities, you can create a mix of supply opportunities as well. And you know, we have to capitalize on some of the infrastructure and some of the impacts we've already had as man in this country, and that's what some of these technologies that the VLH are capitalizing on, the environmental impact that has already occurred, so that we don't have any more incremental impact if we can extrapolate that into something that's more useful. And that's the challenge of that. Now, it's surprising to say, the VLH turbine on the Mississippi, for example, has a capacity factor of about 80%. And in some of the, we just were granted approval from Parks Canada. They had an RFP for developing hydro inside the national park in Ontario on the Trent Severn Waterway. And we were successful with our VLH turbine for 8 installations on their system because we have a low visual impact. We don't change the historic aspects of the existing facilities. Trent Severn was originally developed as a commercial trade route when we had a lot of U.S. Threats coming up, and the St. Lawrence was not necessarily the safest place to transport goods, so the Trent Severn was constructed for that. And some of the Parks Canada historic mandate was to make sure that we recognize that as a society, not just the natural capability of it, but also the social aspect of that. So they wanted to introduce commercial activities, and most of these facilities were built as mills for grinding grain and things of that nature, and now we're converting them to hydro facilities using a VLH turbine. And they're very much encouraging this kind of technology implementation into the existing infrastructure. The infrastructure is collapsing. It had been 80 years old with almost zero maintenance on it. And they needed a revenue stream, and they didn't want to necessarily get money from taxpayers. So what happens when we join onto it, we provide them with a part of the revenue stream as renters of the van, if you will. And they now have taken a cost burden to at least a cost neutral state. So they can sustain the facility, sustain the infrastructure there, and maintain that part of the park through introducing the hydropower. Yes?
Are most of these projects making energy available to remote locations, or are they actually feeding it back into the grid?
Most of them are into the grid. Now, I have done a couple that are replacing diesel in northern BC, as well as northern Ontario. The VLH turbine, because it's a programmatic generator, it goes to an AC to DC, because it produces power at 12 hertz. We need to convert it up to 60 hertz for our North American electrical system. But because it has that attribute, it's able to be operated fully remotely and fully off the main grid from the standpoint of synchronization. So it actually becomes an emergency power supply, if you will, in rural parts of the country, if our grid is designed to accept that. And it is not necessarily that way. The challenge really is one of how do we extrapolate some of the opportunities that these things bring to bolstering up our rather aged transmission system. And if you talk to anyone in the city, you talk about power failures, and we have a couple every year. You talk to someone who lives out in a rural part of the world, and they talk about having to replace TVs, having brownouts all the time, never being able to set an electric clock, things of that nature. The power quality in the rural countryside is substantively different than what we get in the cities. The fundamental there is that when you deploy these out in a distributed network, the VLH is such a small capacity that we're connected to distribution lines, so we don't need any new transmission lines. Distribution lines are used to about 10–15% of their ultimate capacity because they're designed for peak energy distribution. And by putting these types of facilities on that, we make better use of that existing infrastructure. But we also can prop up and support poor power quality through these generators and improve rural electrification.
So would, building transmission lines, is that part of the project, or is that the responsibility?
Normally, we, on some of those larger projects, yes. Like the Pinkston project, we ended up having to build close to 40 kilometers of power line, that on existing power line roads that had to be upgraded. But on the case of the VLH or some of these other technologies, the power lines are right above our heads, and there's very little change to the actual physical. There's some things in the substations and controls and protection equipment that has to be changed, but the actual physical looks of things don't change. Sure.
I was wondering how much energy generated in a hydro plant is required to operate the plant?
The plant itself,
Yes.
very small,
There's no, like,
about 150 kilowatts on a larger plant. And on some other plants, it's less than 100 kilowatts.
And like less than 10%?
Oh, it's less than 0.5%.
Oh,
Yes. Yeah, the parasitic power is pretty low. Matter of fact, in the Pinkston project, which is you see here, just the drainage from the lower tunnel itself, we captured that in a small 8-inch plastic pipeline that we put beside the penstock. We put a small micro turbine in the powerhouse, so that power is actually generated just from the seepage flow coming from the plant. So there, even if we go off grid, we have full energization of the plant. And the actual light bulbs, you wear out your light bulb by turning them off and on. And, you know, we're changing light bulbs technologies, and so instead of turning them off and on, because we have a constant power supply, we just leave them on all the time. Everyone thinks we're wasting power. We're not. We're just utilizing the energy on a most economical basis. And this intake building right here has a micro turbine in it as well, and it we have a little 11 kilowatt micro Pelton turbine inside of it that just takes power from across the height of the gates, because there's no power supply to this building. What we do is we generate our own power there, charge up our own batteries, and the whole system runs off 24 volt DC. And so it communicates by radio telemetry over the mountain peak to the powerhouse. So we have actually a mini hydro plant right there inside the intake building to create its energy too. So you know we're sort of true to our roots. If we go hydro, we go hydro all the way. And so there's actually 5 turbines in this project: 3 energy production turbines and 2 station service type turbines. One at the intake, one at the powerhouse.
Another question. Where is the payback period of time of a hydro plant?
Actual payback, if you did it on a, here's the loan, or here's the lump of money and earn the energy back, is about 7 years on a typical plant. But that is, from a financing standpoint, that's usually taken 20 to 30 years, just for cash flow and leveraging opportunities from the investment. And we're typically looking for a return on investment for a project in around the 12 to 15% range. But with leveraging, I don't know how many of you guys are business people, but with leveraging, some of our developers are enjoying returns in the 25 to 35% range, with all other risk associated to it in the early stages.
Prior to construction, how often do you face challenges with road use and passage rights and people on the native land?
Lots. Yeah, lots. The passage rights aren't such a big problem because the nature of the legislation over time has changed on those roads as resource use roads. So that hasn't been a problem. It's always been a matter of coordination. When we're building our facilities, we do have a lot of equipment in an area for an intense period of time, a year, maybe 2 years sometimes. And therefore, logging activities have to be coordinated with that. But we've been able to work fairly closely with the logging companies and coordinating our activities. They like us because we end up with improving their roads and improving their bridges, and they get that all for free from their standpoint. Now, with respect to First Nations, it's all over the map. We have First Nations that are part owners in a lot of the facilities that we do. We also have First Nations that obstruct everything that we do. So it's a very mixed bag of tricks, if you will. And what we try to do is when we go into an area and we find out whether or not First Nations is interested in the project in the first place, and if so, how. We introduced them to some of the other First Nations that we've done business with before and showed them how they've managed to participate in projects. And sometimes it's just about money, sometimes it's about jobs. But in all honesty, when on the Coal Home projects, which were down by Vancouver, with dealing with the Seashell Dam, which is a very, very far-thinking First Nation, we offered them up to 30% of the jobs on site. And I think we managed 7%, even though the jobs were there, and it just mattered they didn't show up. But they had the offer, and that was the nature of our agreement with them. 7% is not bad. It's by far one of the highest involvements that any hydro facility's been able to achieve so far. Normally it's a couple percent, and that's about all the involvement we get on jobs.